Okay, today our topic is related to light over there. And light is basically, what is light? Light. It is form of energy, is form of energy, which is in the form of electromagnetic waves, which is in the form of electromagnetic waves.
Teacher, I can't see you writing. Like, I can't see the board.
You can't see the board.
Yeah.
Wait a second, I check it. Can you see it now?
Yeah, now I can see it.
Okay. Light, it is the form of energy which is in the form of electromagnetic waves, which don't require any medium, don't require any medium for their propagation over there, for their propagation. For example, the sunlight is coming from the sun and there is a space, still it is reaching on the surface of earth. It means it is not requiring any medium. Like if you are listening my voice, then it means the speaker of your laptop is generating a disturbance which is being giving in the form of parallel waves of the pressure of the air particles to strike on your eardrum to hear my voice over there is the same pattern. As I am speaking, this same vibration is going towards the microphone of my laptop to converting this voice into the digital signal which is being uh, accessed by using internet. And then you are listening my voice over there. It is requiring the medium. Sound waves are requiring medium for the propagation, while the light waves don't require any medium for their propagation, and they are acting as transverse waves also. Transverse
Versus.
transverse waves over there. And because they are, as I said, they are electromagnetic waves, means electric waves, electric field and magnetic field are going to travel in the form of magnetic field in the form of a transverse wave to be created over there. And these light waves are traveling at the speed of 3 multiplied 10 raised to power 8 meter per second. This is the speed of light over there. And this speed of light, we can simply say over there that this speed of light is the fastest speed on the surface of earth over there. And I can say more about them, that those objects which allow the light to pass through them are called transparent objects, parent objects. And there are also translucent objects
And opaque.
and opaque objects. Opaque objects over there. Transparent, which allow the light to transfer through them, like any glass, any transparent water. Clean water is also transparent. Glass and lenses over there are transparent materials which allow the light to pass through on both sides, pass through on both sides. While whenever, mostly when we visit to the offices, what is going to happen? that someone who is sitting inside the office can view the outside area, but outside visitors who are walking outside the office are not able to look inside the office over there. Then that is also a transparent material, but transparent through only one side. Transparent only through one side. Like in our vehicles, we use the black glasses over there. What does the black glass means? Outside passengers or outside road pedestrians are not able to look inside the car over there, but the driver or someone, the passenger who is sitting in the car, can watch outside over there. And opaque objects don't allow the light to pass through. And always remember that light always passes from parallel pathway over there. Light rays or radiations pass straight line or follow the straight line pathway over there. Pass straight line. STRAIGHT. Straight line pathway. Are you there?
Yeah, I'm here. I'm here.
Okay. Pathway. And when you are putting some opaque object in their pathway, if opaque object is there, object is there, then shadow will be formed. Shadow will be formed over there. And if we look towards some transparent object, if transparent object is there, object is present, then light refracts from its original path little bit, refracts from its original path, from its original path little bit. And in translucent object, it is showing the refraction from one side, and other side is behaving like an opaque object over there. And if we go towards luminous and non-luminous objects over there, luminous and non-luminous objects, then I will say here luminous objects are those which have their own lights. The sources of light are called luminous objects. For example, I can say here, what is this happening? Uh, okay, the sources of light, for example, a star. Are you there?
Yeah, I'm here. I'm here. My mic is a bit bad today, though.
It's okay, no problem. Okay, the star, the glowing bulb over there, all of these are the sources of light. When they are behaving like this, then these are called luminous objects. And on the other hand, which have don't their own lights, like the objects which don't have their own lights, don't have their own light, for example, earth, moon. And as I said, the star over here, for example, for solar system, star is sun only over there. Remaining all the planets and moons over there, they don't have their own lights. So those are called non-luminous objects over there. Okay, after this basic explanation of the light over there, now I will move towards a little bit, I will say here, I should go towards the first phenomenon of light related topic, that is the reflection of light. Reflection of light states that whenever of light means when light rays strike on opaque surface, they reflect back into the same medium by showing that they will follow the two basic laws over there. For that purpose, for example, I am taking a plane surface over there in the form of a plane mirror like that, that is having the smooth
Mm.
surface over there. What I am going to do with it, I am taking the two radiations, which I'm taking only one radiation to strike over its surface. Then I am saying this is the point where light ray is striking in this direction over there, and it is reflecting back into the same medium. And I am taking here a normal, a perpendicular line over there, straight line over there to show uh, that there is angle of incidence and there is angle of reflection over there available. So for that purpose, I will simply say here, there is angle of incidence. For this
Yeah.
purpose, I'm saying it is angle of incidence over there. It is angle of reflection over there. This is incident ray. This is
Okay.
normal, and this is reflected ray. And according to the laws which are responsible for this reflection process explanation are going to state like this. Number one, according to laws of reflection, this states that uh, incident ray, reflected ray, and normal at that point lie in the same plane.
And same thing.
Yeah, over.
Okay.
And according to law number two, angle of incidence is always equal to angle of reflection over.
Reflection.
So these two laws are responsible for uh, reflection of light over there. There are basically two types depending upon the surfaces of striking surface of light over there. Then there is regular reflection, and the second one is irregular or diffused reflection over there.
Okay.
If the surface is smooth, as I am giving here the example over there, what will happen that if I am taking in this format, if another ray is going to come, it will come to again in the parallel way. It is striking and it is coming back. If I take another ray over there, then I am taking again the parallel ray. What is going to happen? It is also showing me a proper sequence of pattern of rays to emitting back over there. So I will say this is a regular reflection. The rays are going in this format over there, and for the blue one I am taking also the same pattern, that the surface is smooth and they are reflecting back with the same angle of incidence and angular reflection over there. Then there is a regular reflection. If
Okay.
the surface is smooth, then light reflection pattern will be regular. But if I take Second form of irregular or diffuse reflection, I'm talking about a little bit sandy area over there in a desert. What is going to happen that light is striking in this form and reflecting in this form over there.
That's
Second
irregular.
is again striking in the same going way is the parallel over there exactly, but reflection is too much not following the parallel pattern over there. So if I take another ray for this showing that the ray going is parallel in the same way that the sun is at showing some afternoon time, but the reflection is not too much regular over there. Reflection is totally diffused and it is due to rough surface. Then I will say here, if the surface of if the surface of plane is totally rough, then reflection will be in a random direction, random or diffused direction over there. Okay. Then we will move towards the plane mirror over there. Plane mirror is basically is a regular surface where we will see that the reflection can be seen over there. For example, I am saying that this is a mirror. This is the mirror perpendicularly lying in the on the wall of our home over there in a dressing table room like that. Then I am saying here, for example, there is an object who is standing in front of it. There is a man who is standing in front of it over there. What will happen? The image will exactly form at the same distance from the mirror on the other side over there. And the distance between the object and the mirror over there is exactly equal to distance between image and the mirror. The height of object and height of image will be equal, but the laterally invariant is going to happen. What I will say, plane mirror case I am explaining over there. Plane mirror.
Mm.
This case is going to make the image over there. Image is formed, which is virtual, which I cannot get in the form of a picture like a mobile phone over there, which image is formed, which is virtual. Number one. Number two, height of image, height of
It's the same.
image, yes, is equal to height of object. The distance between mirror and image is equal to distance between uh, object and mirror, between object and
Mm.
mirror over there. So by these three characteristics, we get the image as I am watching inside the mirror by standing in front of it over there. At the number four, I will say the image will be will be laterally inverted. Laterally laterally inverted means my left hand will be right hand over there in the mirror image over there, and my right hand will be like a left hand over there. So laterally, only my left hand will be shown in the mirror image as a right, and right will be shown as left hand over there. So these are the little bit characteristics which were being given with the help of, we can say, plan mirror images over there. After that, there are other two types of images of the mirrors. That is concave mirror, and there is convex mirror. What are the functions of these two mirrors over there? Concave mirror is being used as makeup mirror. It is used in the by the ladies also for makeup purpose over there on their faces. If there are small pimples over there and they want to remove them, they try to use the makeup mirror over there. It is used in medical purposes also, where for example the doctor is watching the teeth inside over there, and the premolars or molars that are the deep inside are not easy to open by the mouth of a small baby over there. Then we will use a mirror that is called concave mirror, and it will be like in this form, like its back side will be polished, and inner curved side will be shiny, and outer side is polished over there. And this is mostly used by makeup mirror or medical purposes. They are definitely be used over there. After that, there is convex mirror, we simply say here they are in this format. Their inner surface is polished and outer surface is shiny over there, and they are mostly available at the blind corners for the traffic over there, at blind corners of the road over there, or blind turns of the road over there. They are fixed by the convex mirror, in which they are going to do two main works. Number one is uh, access the distance of vehicle coming from opposite side, opposite, coming from opposite side, and also uh, also what we can say, and also uh, to judge that driver can pass or he should wait for the car to pass away. Driver can pass or should wait for the other vehicle to pass away, or the driver should wait for other vehicle to pass away, other vehicle to pass
Because.
away. There will be, in examination point of view, we will also go towards mirror image formation over there. Then mirror image formation case, we will just observe where the object is lying. That will be exactly mirror images like you have done or you will do in the transformation topic of mathematics, where there will be a reflection mirror line. Reflection will be the topic over there. The same scenario we will apply for making the images from the objects and mirrors over there. After that, there will be refraction, which we will do inshallah in the next class over there. Refraction of
Okay.
light over there, in which we will discuss about the lenses. Now we have done with mirrors. In that topic, we will go with the lenses, and we will also go towards total internal reflection, critical angle,
Mm.
lenses, and little bit fiber optic.
Okay.
Okay, this was
Okay,
the
sure.
mainly introduction. This is the important topic from which MCQs can be handled and structured question also are going to coming on. And sometimes
Mm.
in practicals, ATP paper, alternative to practical, he is going to consider the question over this topic. So try to make your concepts clear related to this topic, and try to focus on the basic like laws of reflection we have studied today: luminous, non-luminous, regular reflection, irregular reflection, basic nature of light. Over there we can use them in uh, applications over there. All right.
Okay, so in the next class we're gonna do like refractive index, critical angle, total return reflection, everything in the next class, right?
Yeah, because that is basically first related to refraction of light.
Mm.
Then total
Okay.
internal reflection and lenses, and lenses is not explained on your book in detail over there. We will also go with the convex lens five main cases over there. But according to reflection of light, we are done
Mm.
because the plane mirror,
Okay.
concave mirror, convex mirror, regular, irregular, laws of reflection, and basic concept of light over there is enough for
Yeah.
this class for today.
Okay.
Okay. Thank you so much
Okay.
for today. And
No problem,
next
teacher.
class you are having on Tuesday?
Yeah, on Tuesday. And then from the week after that, we're gonna have them on Saturday, Sunday, Tuesday, and Wednesday. Mm.
Okay. All right. No problem. Thank you so much for today.
No problem, teacher. Okay, Allah Hafiz.
Allah Hafiz. Allah Hafiz.